Welcome back, Geometry Scholars. Today's lesson is on properties of and conditions for rectangles, rhombuses, and squares. These three shapes are specific types of parallelograms. Our previous lesson was on parallelograms and what makes a shape a parallelogram, and now today we're going to be talking about three types of parallelograms. The essential question says, how can you determine the similarities and differences between various quadrilaterals? And the objective for today's lesson is that you will be able to define and identify by their properties and conditions rectangles, rhombuses, and squares, and explain how they are related to one another and what makes them a parallelogram. So let's go ahead and get started. Don't forget, if you have questions, write them in the margins of your notes. So let's recap what makes a parallelogram. If I tell you something is a parallelogram, or if a shape is called a parallelogram, that means that both pairs of opposite sides are parallel. So you might want to be highlighting or underlining some of the stuff that I will be. That means the consecutive angles are supplementary, or they add up to 180. Okay, or you could write that they equal 180. Okay, supplementary, they add up to 180, or they equal 180. Both pairs of opposite sides are congruent. So parallel are marked with the arrows, so that side is parallel to that side, and the left is parallel to the right. Okay, that's parallel. The consecutive angles are supplementary, so angle 1, 2, 3, 4. 1 and 2 equal 180, or 2 and 3 together make 180, or 3 and 4 together make 180, or 4 and 1 together make 180. So if they're supplementary, they add up to 180. Okay? If it's a parallelogram, both pairs of opposite sides are congruent. Top and bottom are congruent, left and right are congruent. If it is a parallelogram, then the opposite angles are congruent. Angles that are across from each other, not touching, but across, because they are supplementary to the ones that are touching them. Okay? Opposite angles are congruent. And then the last condition is that both diagonals bisect each other. So this diagonal here, this piece was cut in half, and that diagonal was cut in half. They're not congruent. Parallelogram diagonals are not congruent. They bisect each other. So now we're going to move specifically into the three types of parallelograms that we're discussing today: rectangles, rhombuses, and squares. Okay? A rectangle, besides all those other properties, those are general parallelogram properties, rectangles are a special parallelogram, and they have two more properties. You can see that they're in blue. All of their angles are congruent because they all add up to what? They all equal what? They all equal 90. So they all are congruent to each other, and their diagonals are congruent. So not only when I draw my diagonals am I bisecting them, but more specifically when I draw the diagonals, they're congruent to each other. So this piece, that piece, and that piece, they're all congruent to each other because AC from A to C, is congruent to BD. Okay, so those are the two stipulations that make a rectangle a rectangle. So not only does it have all the parallelogram properties, those are the two rectangle properties. A rhombus has its own properties. A rhombus says that all of the sides are congruent. So as you can see, it's marked. This side, this side, this side, this side. They're all marked with 1. They're all congruent to each other. Their diagonals are perpendicular. So when I draw my diagonal here and here, yes, they bisect each other, just like parallelogram ones do, but more than that, they are perpendicular, which means that they form right angles. Okay, see how I made 4 right angles? And the third thing that it says is that the diagonals bisect the opposite angles. So this diagonal, BD, has cut angle B into 2 equal parts. Okay? Or this angle, this angle has been cut into 2 equal parts. Okay? So those are the 3 properties for rhombuses. A square is special because it's a rectangle and a rhombus combined. So it gets all of the properties. As you can see, and they're color-coded for you, a square, all of their angles are congruent because they all add up to 90. The diagonals are also congruent because it is a type of rectangle. So since rectangles have congruent diagonals, so do squares. So then it also has the 3 rhombus properties, that all of the sides are congruent. The diagonals are perpendicular, and the diagonals bisect the opposite sides. So squares have 5 properties. The angles are congruent. When I draw my diagonals, AC, BD, they're congruent. So not only are they bisecting each other, but they're congruent to each other. All the sides are congruent. The diagonals are perpendicular. So where they intersect, I have these right angles, okay, all around. If this is 90, that means this has to be 90 because they have to add to 180. If this is 90, this has to be 90 because these 2 have to add up to 180. And if this angle's 90, this one has to be 90 because those 2 angles have to add up to 180. So if one of them is 90, they all have to be 90. So squares are also rhombuses and rectangles. So you can say a square is a rhombus or a square is a rectangle, but you cannot say that a rhombus or rectangle is a square. Okay, so a rectangle is not a square, a rhombus is not a square, but a square is a rectangle, a square is a rhombus. Now, today's code word is going to be Starbucks. So I want you to write the word Starbucks in your summary right now. So go ahead and pause this video, write just the word Starbucks in your summary. And when I check homework next class period, I'm going to check to see if you have that word written down. And I'm doing that to see who actually listens to the videos and who is just trying to do it by watching it or on their own. So do not tell anybody what the code word is, or you will not get the extra credit point that I'm going to give you for having the code word down. Okay, so please make sure it's written on in your summary. Let's move down to example 1. We're going to put an X in each box that is a property of parallelogram. So we're going to be using the bullet points that we just filled in. So a rectangle, what does it say about rectangles? It says that all angles are congruent. So we can check that. Blue. And then it also says that the diagonals are congruent. Those are the only 2 things that we know about rectangles. Moving on to rhombuses, again, we're using the bullet points that we just filled in. All sides are congruent for a rhombus. The diagonals are perpendicular, and the diagonals bisect angles. And then squares, it has all of those properties. So everything that a rectangles and rhombuses are, squares are. All their angles are congruent, all their sides are congruent, their diagonals are congruent, their diagonals are also perpendicular, and their diagonals bisect angles. So not only do they have just the regular properties that parallelograms have, they specifically have the properties of rectangle and rhombus. Example 2, for any rectangle FGHJ, decide whether the statement is always or sometimes true. Oh, so either always true or sometimes true. And then draw a diagram and explain your reason. So let's go ahead and first of all, let's draw our rectangle over to the side. F, G, H, J. And remember, I told you that make sure you're naming them in a circle. Okay. Decide whether the statement is always true or sometimes true. So remember, call it a rectangle. So what do we have here? We have that all of the angles are right angles. So is angle G congruent to angle H? So is the answer always true or sometimes true? Well, it's always true. And why is that? Why is it always true? Well, because a property of a rectangle is all angles are congruent. Okay, so angle G is always congruent to angle H because in a rectangle, all angles are congruent. Okay. Let's look at letter B. Letter B says, is JF congruent to FG? Is JF, which is this side, congruent to FG? Well, for them to be parallelogram, Their opposite sides are congruent. Are JF and FG opposite sides? No, they're not. So are JF and FG always congruent, or can that be sometimes true? The answer here would be sometimes true. And when could JF be congruent to FG? When could that be true? Only if that rectangle was a square. So it's a rectangle, but we do have a type of rectangle. It's called a square. So it's sometimes true if the rectangle is also a square. If the rectangle is not a square, it's just a regular rectangle, then that would not be true. But it could be true if the rectangle is also a square. I'm sorry about that. I don't know if you could tell the board just shook, but someone knocked on the wall and said the board just shook bad. Apologize for that. Good example 2. For any rhombus A, B, C, D, decide whether the statement is always true or sometimes true. Draw a diagram and explain your reasoning. Again, I'm going to draw my shape. Just draw it the best you can. No one's grading you on how perfect it's drawn. Name it A, B, C, and D. Okay? Is angle A congruent to angle C? Well, a property of parallelograms is that the opposite angles are congruent. So this would be always true. Okay? Because opposite angles are congruent. Okay? A and C are congruent to each other because opposite angles are always congruent. The next question says DA and AB. Are they congruent to each other? DA and AB. Yes, that would be always true. And why would that be always true? Well, rhombuses look at your first bullet point under rhombuses. Because rhombuses have all sides equal. Or all sides congruent. So angle A is congruent to angle C because opposite angles are always because opposite angles are congruent since it's a parallelogram. Okay, since we know it's a parallelogram, the opposite angles are congruent. And then that's also always true because rhombuses have all sides congruent to each other. Classify the parallelogram. So you're simply going to name what type of parallelogram you think it is. Go ahead and pause the video and try A, B, and C. Okay, example A is a rhombus. We know that it's a rhombus because the diagonals are perpendicular. Okay, so where the diagonals are intersecting, it's resulting in these it's bisecting perpendicularly. Okay, so we have these 90-degree angles. However, we know it's a rhombus and not a square because it doesn't say anything about the actual angles being 90 degrees. We don't know what these angles are, so since we don't know what these angles are, all we know it's a rhombus. It could have been a square. It doesn't look like one, but again, we don't go off what we look like, what it looks like. We go off what we know. Letter B is a square. We know that's a square because we can tell that the sides are congruent. Since it's a parallelogram, we know it's a parallelogram already. Opposite sides are congruent. So that's congruent to this side, and this is congruent to that side. Well, notice they all have one tick mark, so all the sides are congruent. And then also with parallelograms, their angles have to add up. Their consecutive angles have to add up to 180. So if this is 90, that means this has to be 90 also. And if this one's 90, this one has to be 90. And if this one's 90, this one has to be 90. So by default, we have a square. And then lastly, letter C, we know that C is a rectangle because all we know is that we have a 90-degree angle. So we have a 90-degree angle here, This has to be a 90-degree angle, and this has to be a 90-degree angle. So with all these 90-degree angles, all we know is that it's a rectangle. Okay? Hopefully you did well on those. There was one of each. Let's look on to example 5. Classify the parallelogram. Go ahead and pause the video and see if you can get these 3 correct as well. Okay, letter A is a rectangle. All we know is that the diagonals are congruent to each other. See how they all have one tick mark? It means they're congruent. Rectangles and squares have congruent diagonals. However, we don't know if this is a square because it says nothing about the sides. Letter B is a rhombus. All we know is that all the sides are congruent. We know nothing about their angles, so it has to be a rhombus. And letter C, we know this is a square. Not only are the diagonals congruent, which is something rectangles have, but the diagonals are bisecting perpendicularly, which is a rhombus trait. So it has a rectangle trait and a rhombus trait, so it must be a square. Okay, let's go ahead and move on to example 5. Classify the parallelogram, explain your reasoning, and then find x and y. So let's look first. I see that all the sides are congruent, so that means it's a rhombus or a square. But are all the angles congruent? Definitely not. If this angle is 97, they're not all 90, so it's a rhombus. So classifying it, rhombus, explain our reasoning. All sides congruent, but not all angles congruent. Okay? And then we need to find x and y. Well, we know that 5x plus 6 is equal to 8x. So 5x plus 6 is equal to 8x. 6 equals 3x. 2 equals x. Okay. And what do we know about consecutive angles in a parallelogram? Which a rhombus is a parallelogram. Well, they add up to 180. So 12y minus 1 plus 97 equals 180. 12y plus 96 equals 180. 12y equals 84. Y equals 7. So this is a rhombus. All the sides are congruent, but not all the angles are congruent. We found x, and we were able to find y. Okay, example 6 says HIJK is a rectangle. Find the value of x and the length of each diagonal if HJ equals 3x plus 7 and IK equals 6x minus 11. The first thing that you always want to do is draw a picture. Label it HIJK. So it says find the value of x and the length of each diagonal. HJ, so I'm going to draw my diagonal. HJ is 3x plus 7, and then IK is 6x minus 1. Okay? What do we know about the diagonals of rectangles? They are congruent to each other. That's right at the beginning of your notes. The second bullet point under rectangle. So set this problem up to be congruent to each other. 3x plus 7 equals 6x minus 11. Please go ahead and solve for x. Pause the video, solve for x. Okay, solving for x, you should have gotten 6. But now we have to plug 6 in. So HJ equals 3 times 6 plus 7. What is 3 times 6? 18. 18 plus 7? 25. So HJ equals 25. And if we've done this correctly, IK should also be what? IK should also be 25. Because the diagonals are congruent. So 6 times 6 minus 11. What's 6 times 6? 36. 36 minus 11? 25. So are the diagonals congruent? Yes, they are. We have proved it correctly. Please make sure you go ahead and write a summary and at least one sentence of what we've learned today. If you have any questions, please write them down. I'll see you next class. Have a great day. Bye.